हेलो एवरीवन। हम फ्लिप फ्लॉप्स को कंटिन्यू करेंगे। पिछले लेक्चर में हमने पढ़ा लैचेस क्या हैं, फ्लिप फ्लॉप्स क्या हैं। हमने स्टडी किया एसआर फ्लिप फ्लॉप के बारे में, प्रॉब्लम विद एसआर फ्लिप फ्लॉप, मास्टर स्लेव एसआर फ्लिप फ्लॉप एक्सेट्रा। आज हम पढ़ेंगे मास्टर स्लेव फ्लिप फ्लॉप, स्टेट इक्वेशंस, स्टेट डायग्राम्स एक्सेट्रा। सबसे पहले हम स्टडी करेंगे मास्टर स्लेव जेके फ्लिप फ्लॉप। जैसा कि हमें पता है कि अगर एस और आर की वैल्यू हम 1 1 लेते हैं तो हमारे पास एक प्रॉब्लम आती है कंडीशन डिसअलाउड की। सो देयर इज नीड to avoid this condition in case of SR flip flop, whether it is SR or master slave SR flip flop. So the solution is master slave JK flip flop, which allows its two information input lines to be one simultaneously. हम master slave जेके फ्लिप फ्लॉप में, जिसके अंदर हम एक जेके फ्लिप फ्लॉप यूज़ करेंगे, हम इनपुट लाइंस को, बोथ इनपुट लाइंस को वैल्यू 1 दे सकते हैं। आउटपुट ऑफ दिस फ्लिप फ्लॉप विल बी टॉगलिंग आउटपुट। जैसा कि हमने पीछे पढ़ा जेके फ्लिप फ्लॉप के अंदर जो एसआर की प्रॉब्लम है वो आउटपुट में टॉगल हो जाती है, डिसअलाउड नहीं रहती। सो दिस इज द diagram of master slave JK flip flop. This first portion JK flip flop is called master, and the second portion, this one, is called slave. Master flip flop is JK flip flop, slave flip flop is SR flip flop. मान लिया कि हमारा फ्लिप फ्लॉप 1 स्टेट में है। इफ़ वी हैव C is 0, J and K both 1. In case of first one, then due to feedback the output of J gate is 0, the output of K gate is 1. J and K are 1. Then due to feedback output of J gate is 0, the output of K gate is 1. And if clock is changed to 1, the master is reset, because output of J gate is 0, output of K gate is 1. This is, here it is 0, it is 1, as 0 or 1. So the output will be reset. Gate will be reset, master will be reset. If we assume it is in 0 state, C 0, JK 1, what happens? Due to feedback, the output of J gate is 1, output of K gate is 0. J is 1, K is 0. If clock is changed to C1, master is set. If clock is changed to C1, C1 means clock is high. In case of this one, clock is high, it will work, master is set. If we have 1 on J input line, 1 on J input line and 0 on K input line, it will set the flip flop. If in one state it is unchanged, because S and R are set to 0. If in 0 state, S is set to 1, R is set to 0. If we have 0 on J input and 1 on K input lines, it will reset the flip flop. So what do we have? We have this diagram of JK flip flop with master as JK flip flop, slave as SR flip-flop. It solves the problem of SR flip-flop, SR master slave flip-flop of having both input lines 1 1. So the output table is, we have 0 0 0 1 1 0 and 1 1, and in the output we have, when jk 0 0 we have no change state, when j is 0 k is 1 we have 0 reset state, when j1 k 0 we have set state, and when both are 1 1 then we have complementary state. So this solves the problem of master slave SR flip-flop as well as SR flip-flop. So this is the timing diagram of JK flip-flop. When master works, slave is not working. When slave is working, master is not working. So the functions of JK flip-flop and SR flip-flop depend on the control signal, when C is 1, when C is 0. So this is the timing diagram of master slave JK flip-flop. Now there is problem of zeros and ones sketching. See, what is it? The master is enabled during the entire period the control signal is 1. When control is high, master is enabled. And if this slave latch is in one state, then a logic 1 on K input line causes the master latch to reset. See, if this slave latch is in state 1, then logic 1 on the K input line causes the master latch to reset. Slave becomes reset when control signal returns to 0. It is reset, so slave becomes reset when control signal returns to 0. This is known as zero catching at the end of second pulse. If a subsequent one signal on J input line and C is still 1, one signal on J input line and C is still 1, master does not become set again due to feedback is not changing. So if slave latch is in 0 state, logic 1 on the J input line while control signal is 1 will cause the master latch to be set, and slave will be set upon occurrence of the falling edge. Here we have both reset. In this case we will master latch to be set and slave will be set also upon occurrence of the falling edge. This is called ones catching at the end of third pulse. So we have zeros catching and ones catching when both master and slave are set or reset states. This is zeros and ones catching. In many applications, zeros and ones catching behavior is undesirable. Both should not be 0 or 1. Normally recommended that J and K input values should be held fixed during the entire interval the master is enabled. Any changes in J and K must occur while the control signal is 0. So this is all about flip-flops. Now we have characteristics, equations, state tables and state diagrams. We have next state table. It shows the value of the next state of the flip-flop for each combination of values to be present state of the flip-flops and their information lines. The algebraic description of the next state table of a flip-flop is called the characteristic equation of the flip-flop, and obtained by constructing the K-map for Q plus. Q plus means next state output in terms of the present state and information input variables. So what do we have? हमारे पास जैसा कि हमने देखा कि हम अगर फ्लिप फ्लॉप की एक टेबल कंस्ट्रक्ट करते हैं, टेबल देखते हैं, तो हमारे पास क्या है, इनपुट लाइंस हैं, SR हो या JK, T या D। उनके साथ साथ हमारे पास क्या अवेलेबल है, प्रीवियस आउटपुट स्टेट एंड द नेक्स्ट आउटपुट स्टेट, जिसको हम रिप्रेजेंट करेंगे प्रीवियस को Q से और QT से या Q से, नेक्स्ट स्टेट को हम QT प्लस 1 से या Q प्लस से। ऐसे टेबल्स को हम रिप्रेजेंट करते हैं, कहते हैं नेक्स्ट स्टेट टेबल, और उससे जो है एक इक्वेशंस हमें मिलेंगी, उसको हम कहेंगे कैरेक्टरिस्टिक इक्वेशन ऑफ द सर्किट। कैरेक्टरिस्टिक्स टेबल क्या डिफाइन करती है? इट डिफाइंस द लॉजिकल प्रॉपर्टीज ऑफ ए फ्लिप फ्लॉप सच एज ट्रुथ टेबल फॉर ए लॉजिक गेट। QT represents the state at time t and QT plus 1 next state at time t plus 1। जैसा कि हमने पीछे भी देखा, कैरेक्टरिस्टिक्स टेबल जो SR फ्लिप फ्लॉप की है, we have SR 0 0 0 1 1 0 and 1 1, and output QT plus 1 is no change when S and R are 0, so we represent it by QT, previous state. When S0 R1 we have a reset state, when S1 R0 we have set state, and when S and R both are 1 we have undefined or invalid input. Similarly we have table for D flip flop. In this case the characteristic equation is QT plus 1 is DT. It is very simple to understand. Similarly we can have next state tables for other gates also, for JK flip flop, for T flip flops. See, we have seen these tables: SR flip flop, for JK flip flop, for D and for T. In this case we do not have previous state. If we include in these diagrams the previous state also, we have table like this. These tables can be converted into these tables. These are called next state tables. We have S0 R0 S0 R0 value, previous value 0 1 and so on. The output, the current output, or you can say the next output, can be shown like this. Here we have previous state 0 1, we have reset, we have set state and invalid state. In case of JK flip flop we have previous state, reset state, set state and complementary state. In case of D flip flop, as we have seen, this is the case 0, this is reset, this is output as DT, and this is the T flip flop, toggle flip flop. We have when toggles means both inputs are 1, T is 0, previous is 0, output will be same, and when T1 is 0, output is 1, toggles only. So this is the case of SR, JK, D and T flip flop. Now see this table, SR flip flop. Here we have S, R and Q as 3 input lines, and we need an equation for this Q plus or Q T plus 1 state. So we will be having K map for 3 input lines as S, R and q, and we will get q plus or q t plus 1 as output. This is the equation we had from this K-map. Similarly, we can have the characteristic equation for JK flip-flop, we can have for D flip-flop and T flip-flop. So we can see that in case of T flip-flop, there is an exclusive OR gate between T and Q. Now we will analyze different sequential circuits. What does analysis contain? It consists of obtaining a suitable description that demonstrates the time sequence of the inputs, outputs and the states: current input state, previous output state and next output state. Logic diagram, we will be having Boolean gates, flip-flops if any, and appropriate interconnections between them. And the logic diagram is derived from any of the following: by Boolean equations using flip-flop inputs and outputs, will be having state table and then state diagrams. Let us suppose we have this circuitry. We will analyze this circuit, the behavior of this circuit, and in this case we will be having Boolean equations, state table and then state diagram to analyze the circuit. Here see, we have two gates, two flip-flops, this one and this one. The output of flip-flop is A, this one is B. We have input line X and we have another output line Y. So we have input X at time t, simply we will say X, output line Y, states are A and B. So what is required? Output function of this diagram and what is the next state function. So what do we have in this circuit? We have these gates, this one and this one. So if we use our Boolean algebra, what do we have? We have A t plus 1. For this flip-flop, we have this one. In this case, we have this and B to this gate also and so on. So we have A t plus 1. Next state of the A will be AT and XT, or with BT and XT. Similarly, we will be having BT plus 1 equal to A complement T and XT. YT will be X complement T and BT plus AT. जैसा कि हम डायग्राम से देख सकते हैं, ये हमारा सिंपल बूलियन अलजेब्रा है. हम एंड और से हमारे नेक्स्ट स्टेट इक्वेशंस को देख सकते हैं. व्हाट विल बी द इनपुट टू द डी फ्लिप फ्लॉप्स एंड आउटपुट वाई. स्टेट टेबल कैरेक्टरिस्टिक्स क्या है? State table is a multiple variable table with the following four sections. We had present state, the values of the state variables for each allowed state, input, the input combinations allowed, the next state, the values of the state at time t plus 1 based on the present state and the input lines. And fourth one is output, the value of the output as a function of the present state and the input if any. So from the viewpoint of the truth table, we had input and present state, and the outputs are the output and the next state. So we have the state table of the given circuit as we have present state as AT and BT, and the next input is XT. So using these three, AT, BT and XT, we can have next state AT plus 1 and BT plus 1, and depending on the next state and input states, we can have YT. So from these three equations, AT plus 1, BT plus 1 and YT, our state table is this one. We had only AND gate and OR gate, complementary gate, AND gate and OR gate. Simply using the truth tables of AND gate, OR gate, NOT gate, we can make state table of our given circuitry. From this, we see that here present state, the next state and the output. So if we analyze these present states and these next state and the given input value, we can construct a state diagram. So the rules for state diagram are: a circle with the state name is in it for each state. A circle with the state name in it for each state. A directed arc from the present state to the next state for each state transition. एक सर्कल रिप्रेजेंट करेगा एक स्टेट को. अगर हम एक स्टेट से दूसरे स्टेट पे जाना चाहते हैं तो एक डायरेक्टेड आर्क का प्रयोग करेंगे. And a label on each directed arc with the input values which causes the state transition. हम डायरेक्टेड आर्क के साथ एक लेबल भी दे सकते हैं जो ये बताएगा कि जो ट्रांजिशन हो रहा है वो किन इनपुट वैल्यू से हो रहा है. एंड ए लेबल ऑन ईच सर्कल with the output value produced or on each directed arc with the output value produced. So the state diagram for the given circuitry can be shown like this. See this table. We have present state and input. We have next state and the output. So this is the state diagram for this table. See A0, B0, X0, A0, B0, Y0. So if we had this state A0, B0, we will move when X0, the output state is 0, so it will revert back to its own position. When X is 1, A0, B0, X is 1, so A0, B0, X is 1. So we had next state 0, 1 and output 0. So we have this state one, this one. When X is 1, Y's output is 0 and the next state is 0, 1. So similarly we can construct a state diagram for the complete state table. So this is all about flip-flops and state diagram, state equations, state tables, or we can say flip-flops and the circuit analysis with flip-flops. Thank you very much. If you have any query, you can inbox anytime. Thank you very much.